So Carlos coming from Ambiq Micro, as I said. I'm getting a notification on my watch here. This watch, it's a Garmin watch powered by an Ambiq Micro chip. I charged this last Friday. I still have 9 days of battery life left. So, having 1 day of battery life in a smartwatch seems very backward to me. So it's with thanks to companies like Ambiq that we can have these devices that last a super long time. And Carlos, I think you're going to talk about, Carlos, you're a VP looking after AI, right, within
my job,
Ambiq. So with that, let me hand over to you.
All right, thank you so much. Yeah, and I'm going to hammer that power message all the way through my talk. So my name is Carlos Morales. I work for a company called Ambiq, and we're going to take it past where we were. When we say edge, we're basically talking about almost the edge, right? If you go past a smartphone, you go past a smart hub, you find the edge, the thing where you cannot go any further. That is the endpoint. That is the endpoint of AI, and that is where Ambiq plays, where every microjoule counts. And you still want to do AI and very deep analytics. That's where our products are strongest. So, and it is kind of a transition that we've been through, right? We went through the smartphone. I think we've seen this theme today, many presentations. We went into the IoT world. Everything is connected, and now you're bringing IQ all the way down to that, and that's what Ambiq stands for, right? It's not Ambiq, it's Ambiq, it's ambient IQ. And this company was started a long time ago, so our founders were thinking about this more than a decade ago. I don't think I need to tell this audience how important Edge AI is. So I'll kind of skip through here, but if you kind of look at the highlights here, the most important thing, I think, from the cloud all the way down to this endpoint is power. We are engineers. We're always constrained by memory, by compute, and also by power. We've learned, and we've gotten very good at the other two, and we've learned to deal, we just kind of accept that everything is going to be, don't redesign your chip, just buy a power plant. Literally, that's what Microsoft is doing. So we're trying to solve the power problem. Okay. Now I know the fonts are small, but the vertical here is battery life, and the bottom is AI capability. It's a proxy for how complex your model is. The more complex you are, the more your battery life is going to suffer. So this is the life of every system engineer. You have to find a point on that curve where you feel comfortable compromising. You can make a very sophisticated model, and your battery life will be an hour, and it's more of a product demo, right? It's a nice lab demo or a CES demo. That is not something you can sell at Best Buy, right? Your consumers are not going to be happy. So we've learned as system engineers over the last, decades, to kind of feel where this stuff is. Right? Anything above that, your customer will be happy. 8 days of Phoenix, super happy. The biggest problem with Garmin's is you forget to charge them because you just never think about charging. This thing, I have an Apple Watch, which we don't sell to, so I shouldn't wear it. This thing I have to charge it every night, right? So that is a big happiness thing. If the battery life is too low, so 24 hours is right at the limit. If it's a 3-hour thing, and I'm thinking the Rabbit R1, recent Edge device, smart glasses. We've all saw the Meta announcement. They announced something called Orion. A big problem with Orion is it lasts, less than an hour. That is not a practical device, right? You have to have a puck. Humane has the same kind of problem. Big Humane innovation is they have a wireless battery charger that also serves as your pen. So anything below that is just not practical. And in the middle, that feature better be really good. And I think that endpoint, smartphone, LLMs fall into this. You're using a lot of battery to enable that LLM functionality. Are you happy with it? Is it really worth that battery hit? And you have to be, as a system engineer, you have to be very careful about making that choice. So I like to call this the practical zone. This is yeah, of course, do it. This is easy enough. This is things like wake word, things that run constantly. You're not going to kill your battery. Iffy zone, yeah, it's cute if your phone can compose a sonnet for you, but is it really necessary? Are you willing to give up an hour of battery life to do that? And then the CES zone. I've seen so many devices at CES that work really well and they never make the market because, by the way, you're not showing you the huge battery that you have to wear. So that's the day in the life of a system engineer, and it's a tough kind of compromise that you have to make. What Ambiq does is it kind of expands that curve, right? Our battery life is longer, and here is not to scale, by the way. Our chips are between 3 times and 10 times more power efficient, cycle for cycle, than another chip. Any other chip is not manufactured using our technology. And so, actually, let me do this to scale, right? So let's kind of squish this one down in the corner. This is the same graph as we had before. And now we draw, the Ambiq thing. And here I'm just using 3x. But for some AI, for especially the heavy convolutional kind of AI, it's more like 10x. And what does that mean? Well, you still have all this stuff that's not practical, right? There's still, like, I can run a large language model using external SRAM, and I can show generating tokens, and it sucks. It's never going to go into your smartwatch. It's just, you don't need your smartwatch to compose Shakespeare. Maybe you do, but I don't. Oh, I don't. Right. So there's always going to be that iffy stuff. But the practical zone gets huge. There's so many things that weren't even conceivable before. Now that you have 3 times, 10 times the power to play with, they're now real. And I actually go into customers where my biggest challenge is they have, I have this beautiful audio model. I just can't run it because it lasts an hour. Like, no, it lasts 10 hours. Let me explain how, right? So that is the biggest, after 10 years of battery abuse, my biggest challenge is getting that Stockholm syndrome solved and saying, no, you can really do amazing things on your battery. So that's it. This is my life. My job at Ambiq is basically how do I take advantage of that practical zone? How do I show what kinds of models typically do not run at the far endpoint? They've been shoved into smartphones or into the cloud. How do I show that those models can actually run on device, on battery-powered devices in a practical manner? And we have some demos outside. If you have some time, drop by. I'm happy to talk about them. So that's the background. That's why we exist. That's the reason for Ambiq to assist, is we make similar chips to what everybody else does. We make Cortex chips. We put really nice peripherals on them. And then we cut the power by 90%. That is our mission. We're still a startup. We are a couple of hundred people spread over the planet. We have a lot of protective patents, over 200, way over 200 customers. It's startups go through this. If anyone here is from a startup, you have the one big customer, you have the 10 big customers. That's a big jump. And then you go to 100 and you're in trouble because you have to do business different. And now we have thousands and we have to do business different again. We have to find ways to scale. Fun stuff. It's probably the funnest I've had in my career. I've only been there 3 years, so I'm sure the people who were there before were having less fun. And we go into every kind of device. Like if battery is important, and you can imagine if you have a smart ring, battery is the most important, because how much battery can you stick on a ring, right? And if the ring lasts an hour, that's not going to fly. So we go into things like smart rings, smart watches. If you go into REI, big chain here in the Bay Area, and you go into the wearable section, all the fitness bands and everything, we're in every one of those devices, almost every one. There's a handful that we're not in. And then, of course, smart home, AR, VR, super exciting. I think during the panel, I'd like to get into that a little bit. Because now you're tying this sensing device to a large language model. And this sensing device is so capable of capturing the context around you, but it needs onboard AI. That the Orion, beautiful device, but what I'm watching that Orion kind of presentation, I'm like, oh, that's AI, that's AI, that's AI, that's AI, and it's all running here. It's not running because of the latency. You know that it's not running in a smartphone. It's definitely not running in the cloud. Okay, let's see, one more slide so we can catch up. This is how we do it, by the way. The company was founded on the principle of operating transistors where they should not work. Like you go to college, you're an electrical engineer, you know that a transistor works above a certain threshold, you're a 1, below a certain threshold, you're a 0, and in the middle is no man's land. You don't want to spend any time there because your transistor won't work. It's like a 0.751, right? It doesn't work. Turns out that's not exactly true. That's just safe. Right, so when you want it to work at the 0.75 or 0.5, you have to be very careful about temperature, voltages, all those things start playing havoc with your transistors. What Ambiq has done is solve that problem. So you saw, these are smartwatches. They go on your wrist when you're running in the sun. We don't care. Like we have all this technology on the chip that is monitoring temperature, monitoring voltages, and keeping those transistors in the optimal voltage range. And the result is, we can drop the voltage. Instead of going to 0.8 volts, so we're 0.7, 0.6, depending on temperature and all that stuff. And power is voltage squared. So the payoff is huge. And literally, the day I was hired, 1 week later, I get all my eval kits. I run MLPerf, which is the AI benchmark. Everybody here has run MLPerf. And I measure the power because I didn't believe them. A startup is going to recruit you. Yeah, whatever, 90x. I thought I'd drop to 0. The thing literally uses 1/10 of the power of what it should. Right? And then when I hugged my wife, I said I chose wisely. This is not free. Like there's a lot of software that you have to do. You have to think. I don't have 3 billion parameters. I have 300,000 parameters, right? I have to get really clever about how I use those parameters. So I was watching all the compression and, teacher, student distillation and all that stuff, and that's cute, right? That's cute. For these things to work, you actually have to rewrite a lot of the models to fit in these devices, and we're doing a lot of that. Like it's kind of a neglected corner of the world, but it is. Like, let's put it this way. Right now, nobody is probably using ChatGPT. Maybe a couple of people in the corner. But everybody's running AI. All your smartwatches, all your devices, not the cameras that are too old, but modern cameras, they're all running inference all the time. AI surrounds us already. It's not one of those future things. We're already there. And so my job is to make more AI run all the time. And so we've developed a big software package to do that. We call it NeuralSpot. NeuralSpot is kind of a marketing term. There's a bunch of different products in there. When I joined, I told you, the first thing I did was run all this stuff. It was super hard. It was a lot harder than it should have been. So I set out to create tools to make that deployment to small devices easier. So that's what we have now in NeuralSpot. And then we have a family of products all the way from very, very extremely low power, like ludicrously low power, Apollo 3, all the way through the Apollo 5 that we have outside, that is capable of running object detection and speech ASR and all this really cool stuff. I look forward to talking more about all of this during the panel, but I know that I'm getting hungry. So, I think I beat my time.
Excellent. Thank you very much, Carlos. Thank you.